Hurricane Erin, a name that will surely be remembered for decades, has completed an extraordinary journey across the vast expanse of the Atlantic Ocean. This storm began its life weeks ago, first making its presence known near the Cabo Verde Islands on August 11, 2025. From these humble beginnings it grew with astonishing speed and intensity, feeding on the unusually warm waters of the Atlantic. It quickly became a fearsome Category 5 hurricane, the highest and most dangerous rating on the Saffir-Simpson scale. This classification is reserved for storms with catastrophic wind speeds, capable of causing widespread destruction and devastation wherever they make landfall, representing the pinnacle of nature's raw power. What made Erin so particularly noteworthy during its initial phase was not just its incredible strength but also its sheer size. Meteorologists watched in awe as the storm's wind field expanded, eventually rivaling the enormous size of Hurricane Sandy from 2012. This massive scale meant that its influence was felt over a huge area, churning the ocean and disrupting weather patterns far from its core. For a time it posed a significant threat to the United States East Coast, prompting widespread alerts and preparations. The storm tracked menacingly close to the coastline, but ultimately it veered away, sparing North America a direct and potentially catastrophic hit, a fortunate turn of events for millions. As Erin moved northward into the colder waters of the North Atlantic, it began a process known as extratropical transition. This means it started to lose its classic hurricane characteristics like its well-defined eye, and began to transform into a different kind of powerful storm system. However, this was not a weakening in the traditional sense. Instead, it evolved into a massive and potent post-tropical cyclone, retaining much of its energy and, crucially, its vast reserves of tropical moisture. This transition is a critical part of its story, explaining how a storm born in the tropics could maintain enough strength to travel all the way to Europe and still pose a major threat. This transformed storm, now often referred to as ex-Hurricane Erin, set its sights on an unusual target, the continent of Europe. It is exceptionally rare for the remnants of such a powerful hurricane to maintain this level of organization and energy over such a long distance. Typically, these systems dissipate over the cold Atlantic waters long before they can reach European shores. Erin, however, is an anomaly. It has defied typical meteorological expectations, carrying with it the warm, moist air from its tropical origins. This moisture-laden air is the fuel that will soon power a severe weather outbreak across a large portion of Western and Southern Europe, a region largely unaccustomed to weather events of this magnitude. The journey of ex-Hurricane Erin towards Europe is now creating a highly dangerous weather setup. As the main storm system, or deep trough, approaches the continent, it is triggering the formation of a secondary low-pressure area over the Mediterranean Sea. This new system is acting like an engine, pulling vast amounts of warm, humid air northward from the sea directly into southern Europe. This influx of moisture is creating an extremely unstable atmosphere, with energy levels forecast to exceed 3,000 joules per kilogram. This is a very high value that indicates the potential for explosive thunderstorm development, including powerful supercells that can produce the most severe weather phenomena, turning the sky into a battleground of natural forces. The timeline for this severe weather event is unfolding rapidly and will last for several days. The outbreak began last night on Wednesday, with intense thunderstorms developing over northeast Spain and southern France. Today, Thursday, the focus of the severe weather is shifting eastward. The storm's energy is now spreading across northern and central Italy, the Alpine region including Switzerland and Austria, and into the Adriatic region. By Friday, the system will continue its eastward march, bringing its dangerous weather to the northern and western Balkans. The event is expected to conclude on Saturday as the storm's influence reaches southern Italy and the southwestern Balkan Peninsula, leaving a wide trail of impact. The primary and most widespread threat from this multi-day event is extreme rainfall, which is expected to lead to significant and potentially life-threatening flooding. Forecast models are predicting staggering rainfall totals, with many areas likely to receive between 100 and 200 millimeters, or 4 to 8 inches, of rain over just 72 hours. In mountainous areas that force the moist air to rise and cool rapidly, such as the Aosta Valley, Piedmont, and other parts of the Alps, Rainfall could exceed a catastrophic 300 millimeters or 12 inches. This volume of water can quickly overwhelm rivers and drainage systems, leading to flash floods and dangerous landslides in the rugged terrain. Adding to the complexity of this weather event, the powerful southerly winds associated with the storm are transporting a large plume of Saharan dust across the Mediterranean. This dust is being lifted high into the atmosphere and will be carried into the Alps and other parts of Europe. While it can create hazy skies and spectacular red-hued sunrises and sunsets, it also has a more serious impact. The dust particles can act as nuclei for raindrop formation, potentially enhancing the intensity of the rainfall. This combination of tropical moisture and desert dust is creating a unique and volatile atmospheric cocktail, heightening the overall risk and making the storm's behavior even more difficult to predict with complete accuracy. The list of countries in the direct path of this severe weather outbreak is extensive, placing a large portion of the continent on high alert. The regions most at risk include northeastern Spain, the entirety of southern France, Switzerland, and much of north-central Italy. The threat then extends eastward across the Alpine region into Austria, the Adriatic region including Slovenia and Croatia, and finally into the northern and western Balkan countries such as Bosnia and Herzegovina and Serbia. For these nations, the coming days will be a critical test of their emergency preparedness and response capabilities as they face weather conditions that are far beyond the scope of a typical late summer storm, requiring vigilance from both authorities and the public. Residents in these affected areas must prepare for a dangerous combination of weather hazards. Beyond the extreme rainfall and widespread flooding, the storm will bring powerful and potentially damaging winds. These strong gusts can topple trees, damage buildings, and cause widespread power outages. Furthermore, the atmospheric instability is so high that there is a significant risk of large hail and even tornadoes. These tornadoes could form rapidly within the most intense supercell thunderstorms, posing a localized but extremely severe threat to life and property. Along the coasts, particularly in the Mediterranean and Adriatic, the strong winds will also generate rough seas and the potential for waterspouts to form. This storm system is highly unusual for Europe, primarily because of its tropical origins. Most storms that impact the continent are mid-latitude lows, which form in a completely different way, and typically contain much less moisture and energy. Hurricane Erin, however, is fundamentally different. It is carrying the remnants of its tropical past, meaning the air masses involved are far more robust and loaded with moisture than what Europe normally experiences. This tropical connection is the key reason why the rainfall is forecast to be so extreme, and why the potential for severe thunderstorms, including supercells, is so unusually high for this part of the world. Given the severe nature of the forecast, it is crucial for everyone in the affected regions to take this threat seriously and prioritize safety above all else. People should stay informed by closely following official weather warnings and heeding the advice of local authorities. It is essential to avoid travel if possible, especially in areas prone to flooding or landslides. Securing loose objects outdoors, preparing an emergency kit with essentials like water and flashlights, and having a plan to stay safe are all vital steps. This is not a normal storm, and treating it with the utmost caution and respect is the best way to protect yourself and your family from its dangerous impacts. While inland areas brace for rain and wind, the coastal regions of Europe are preparing for a different but equally historic phenomenon: a massive ocean swell generated by Erin during its time as a powerful hurricane in the open Atlantic. This is not a typical summer swell, it is a winter-sized event arriving at the peak of the summer holiday season. The storm's immense power and vast wind field churned the ocean for days, sending powerful waves traveling thousands of miles across the Atlantic. These waves have retained their energy, and are now set to crash upon the shores of Western Europe, creating conditions that are both spectacular and extremely dangerous for anyone near the water. The world-famous big-wave surfing spot of Nazaré, Portugal is forecast to experience something truly unprecedented for this time of year. Forecasts are calling for wave faces that could exceed an astonishing 60 feet or over 18 meters, driven by a long-period swell of 20 seconds. This combination of size and power is typically only seen during the fiercest winter storms. Big wave surfer Nick van Rupp has called it the earliest XL swell in recent memory, emphasizing that he has never ever seen waves of this magnitude in Europe during the peak of summer. The massive swell will also impact other coastlines including France, the Canary Islands, and Morocco, creating dangerous coastal conditions and powerful rip currents. The arrival of a storm like Erin in Europe inevitably raises important questions about the role of climate change. Hurricanes derive their energy from warm ocean waters. As global temperatures rise, the Atlantic Ocean is becoming warmer, and these warmer waters are extending further north. This provides more fuel for storms to form, intensify rapidly, and maintain their strength for longer periods and over greater distances. While it is difficult to attribute any single weather event directly to climate change, a storm with Erin's strength, size, and unusual track is consistent with what scientists expect to see more frequently in a warming world. In summary, Hurricane Erin represents a landmark meteorological event for Europe. Its journey from a Category 5 monster in the tropical Atlantic to a severe weather-producing system over Europe is a stark reminder of the atmosphere's power and interconnectedness. The combination of inland flooding, damaging winds, and a historic summer ocean swell poses a multifaceted threat to millions. This event serves as a powerful warning, highlighting the increasing possibility that destructive, tropical-origin storms could become a more common feature of the European climate in the future, forcing the continent to adapt to a new and more volatile reality.